Okay, welcome back. And today we are revisiting, once I adjust my camera, because I'm sure it's dropped. Bear with me. That's a bit better. Yeah. Here we go. A Rockseed variable output power supply. It's got 6 memory functions: over voltage protection, over current protection, constant voltage, constant current. Yeah, a mains power on off, but also an output power on off, which I do like, and I like the memory functions as well. That's why I paid a little bit more for this one. But if you've seen the previous video, I had an issue with this, with the inrush thermistor. It was popping, and I'm sure I've got the old one around here somewhere, which I was going to show you, but I don't know where it's gone. Just bear with me. I could have sworn I saved it. Just in case I needed to refer back to it. And I'm sure it will be around somewhere. But nowhere that I can see at the moment. But anyway, they basically they look like these things. It's a little bit bigger than that physically. These are 20 ohms. So I replaced it with one of these. And then within 2 days, if you've seen the last video, you'll see at the end, within 2 days, it started doing the same. So I was getting a spark. If you watch the first video, you'll see the spark. I slowed it down and did a little bit slow motion. Just an initial power up. It didn't affect the operation of... That's all over the floor. It didn't affect the operation of the power supply. It still output the voltage very accurately. As I say, it's just the inrush thermistor to try and smooth out the sudden inrush of current. Now I did try and find an equivalent, because the previous ones were 20 ohm. The only numbers, I'm not doing very well today with these screws, am I? The only numbers it had on was 20, it was NTC, 20D11, I think it was. So that was 20 ohms, and the 11 stood for 11 millimeters in diameter. Tried to find some of the same and wasn't very successful. So I didn't initially know what the numbers are related to. So I reached out to another YouTuber that I follow, BigCliveDotCom. It's a brilliant channel. If you like your electronics and reverse engineering of things, give his channel a view. Very, very good. Very knowledgeable person. But yeah, I reached out to him, asked him about the numbers, what they're related to, how I could calculate if I had the correct size. It should be, because that's what came in this from new. And he basically told me, we checked a few other things, if there was a switch or anything nearby, but there isn't. and this is physically smaller than the original. So he said you can do one of two things. You can either reduce the resistance, or you can increase the physical size so that it can carry more current without popping. So I bought a few different ones from RS Components. That's probably around about the size of the original, but it's only 16 ohms, so that's dropped in size. Dropped in resistance rather, it's around about the same size. This one is 15 ohms, but it is substantially bigger, so I might go with that one. If I drop the resistance down even further to 10 ohms, which is half than what was originally in here, but it's a nice big thing. Maybe it's too big. Would that even, don't know whether the thickness of the legs would be too, I don't know. So we'll maybe hold off on that one. And some more 16 ohm ones, which is that, but a little bit bigger. A little bit bigger physical size. I think this is not far off the original, so that's a little bit bigger. I'm going to go with this one initially, and we'll see how this goes. So you never know, you might get a third video out of this one. So this is part 2. So this is 15, 21, 26. I don't know what the 21, 26 stands for. 15 is the resistance, and let's just double check that. Let's see if we can bring that in. Are you able to see that? I need a new battery, but oops. There you go, 15.5 ohms, 15.6, 15.7, yeah, 15 ohms, maybe 16. So that's all good. What the 2126 stands for, I don't know whether you can see that. 2126, I'm not sure. Because that's 14, 15 mil across, and it's probably about the same. Yeah. So it's certainly not to do with the diameter. Let's get the old one out. Let's get this one in. We've dropped it in resistance value by 5 ohms, and it's slightly bigger than the original. So hopefully that will work. Excuse me. I'm knocking things off my desk. I need to have a good tidy up. It's just far too much junk lying about. I don't know how well you can see that. Let's try and get this one in. You can see it's actually where that last one exploded. It's left a scorch mark. Now that wasn't there when the first one was popping. So that's obviously off the second one. So that goes in there. I could have taken this whole board out, to be honest. So that's in place. I'm just going to try and go on. Is that hole too small? I think it is. Well, the first leg's gone in all right. So why is that one too small? Surely the holes are the same size for each leg. just wasn't lined up properly. So just to ease it in, do a few millimeters each side. Bend these up slightly so that they're a bit easier to get off at a later date. I'll say a later date, once I finish soldering. Yeah man, keep going, keep going. Now if this goes pop, I'm expecting it to be considerably louder than the last two. Which, to be fair, gave a canny crack, as they say. It's my accent coming through. So, two legs. Just want to make sure it's soldered sufficiently. Yep. Solid. So plug this in without putting the, if I can stretch my power lead over, lie this back down. Can you see that? Right, power on. No spark? Okay, I'm going to set that to 32 volts. I must admit, the first, when I changed it, it did take a day or two before it popped again, so I may just have to monitor it for a few days. So if this video ends here with no message at the end, then it's all good and it all worked. Otherwise you'll get a little message saying it didn't work. Seems good. I'm going to say that's a fix, but I'm going to keep my fingers crossed for the next few days because I thought that last time. I am going to try something because someone told me, I watched a video to say that, let's zoom back out, we could program this, and this would, you could program a beep, and I'm just trying to remember, it was press and hold that. So I'm going to need to plug it in. I don't know how easy this is going to be to show you, but press and hold that while you turn it on. Yay. And if you press that again, beep off, and press the M4 button because that's illuminated, beep on. So I don't know what those are. Address 1, that's for when you use the software on the PC, so you give it an address, so the I think it's like a COM port. Beep on, okay. So now when I press a button I should get a beep. When I turn the dial, yeah. We'll see how I go with that. I might get annoyed with it after a while. I don't adjust it very often, but it's nice to know that when you're changing the memories, if you press it once, it shows you what the memory is and you can adjust it. but if you want to change to that preset or memory, you've got to press it twice and then it selects it. So it's nice to know that 2 presses have worked, because sometimes if you don't press them quite right, you don't know. I tend to leave it on that because that's my, I think it works out at about 60 or 80 watts for my MacBook. So when I'm testing MacBooks, which I might have to make a video of one day. Let's have a look. Oops. Yeah, MacBook. Stick the mag lock on there. Maglock. MagSafe. Just to power it up. We'll see. You'll maybe get a video of one of those in progress. So yeah, I'm going to put the cover back on this and I'm going to run it for a few days. And by that time I should be around to editing the video, and I'll be able to put a little message on the end to say whether it's been a success or not. So, I know I said it last time and I was incorrect, but this time I'm almost certain that that is a positive fix.